voice is not audible, sir.
Just a second. Is it audible now?
No, sir.
Ma'am, is it audible now? Ma'am, is it audible now?
No, sir.
Okay, fine. Thank you. So, as I was stating,
Yes, sir. Yes, sir. Now it is audible.
okay, thank you very
Audible,
much.
sir.
Thank you very much. So, as I was stating that in the morning session, we just studied some introductory part about big data, data analytics, and how data analytics works. And towards the end of the session, we started some hands-on practice on data analytics tool called Simulink. So I'll just state you that what we are going to do in this particular session, and what the index is going to be. We'll just continue on the tool that we started in the morning session. We will do some hands-on practice and some real-time data analytics that we will be doing. Now, that particular tool is connected to big data and data, real-time data analytics. But there is another concept to this data, real-time data science, that is Hadoop, and we need to practice some real-time tool regarding Hadoop as well. So after implementing this particular tool on big data analytics, I will be introducing you about some core concepts and some in-depth concepts of Hadoop. And after introducing to you the in-depth concepts of Hadoop, we will do a hands-on practice on another tool that will implement basic Hadoop, advanced Hadoop with big data analytics. So in practice, we are going to we are going to see two tools in real time, in hands-on practicing, and how these two tools works. So first of all, I'll just continue with the tool that I started in the morning session. I'll take 1 or 2 minutes to just open the tool. Yeah, I hope my screen is now shown to all the faculty members. Ma'am, my screen is visible to you?
Yes, sir.
Okay, fine. Thank you very much. So here, as I was stating you in the morning, let me just reiterate what I stated in the morning. This is a very important tool and it can be very useful to all of you going forward into your big data analytics and real-time applications of big data. As I told you, we in this particular uh, practice session, we will be implementing this tool Simulink as well as Python. We will be practicing a task. First, I will explain you how to do it. Then I will help you to do a hands-on practice on this particular tool. What I did, I opened MATLAB window, and in the command window, I just wrote Simulink. And after typing Simulink, a Simulink, command window was opened. It will open to all of you if you do this. And after opening this command window, on the left-hand side here, as we can see, that there are various tools. Okay, these are all my inbuilt blocks. I don't have to write chunks of codes to implement them. They are just plug and play. Okay, and here are these blocks that I was talking about. If I click on any of these blocks, many options will come, and they are, it's a huge library, and I can use any of these blocks without any problems. So this is the introduction to this particular tool. What I'm going to do now, I'm going to simulate or implement a real-time scenario using this tool that involves big data and big data analytics. I'm considering a scenario of a office or a railway station where a large number of, say, employees or customers are coming in to the station to buy tickets. Obviously, when the customers will be coming in, there will be queue of customers, and along with the queue, there will be service windows also available for a particular employee or a particular customer. So what we will be doing is we will be manually implementing all this scenario, and we'll be seeing that how it works. Now, first, I went to this particular part, that is generators, and in this particular part, I went to I just opened this, and I opened entity generators, and I choose time-based entity generator. I right-clicked on it, and it showed me an option of add block to this particular model. Okay, so I added it, and this is my structure. This is my time-based entity generator right here on the left-hand side. I just open its parameters by double-clicking it. These are my parameters. Now, why I have chosen this time-based entity generator? This is the question that must be arising in your minds. Okay, so why I have chosen this? Because whether I take the example of an office or I take the example of a railway station, the customers or the passengers or the employees will be coming with instance of time, isn't it? So suppose there are 500 employees in an office, or 500 customers walking into a railway station. So they will be coming with passage of time. Suppose passenger number one comes at time instant t1, passenger number two comes at time instant t2. So for this, I need this time-based entity generator. This block keep tracks of the time, and this is the best block that I can use to implement my incoming employees or incoming passengers. So I opened its properties. I set its lowest value to 0, and I set its maximum value to 20. I could do it for even 200 passengers, 2,000 passengers, 20,000 passengers, 2 lakh passengers, 20 lakh passengers, or more. Uh, this is an example that how easy this tool is, and this gives me a complete control over the scenario, and I could implement these things in real time. For now, just do it for 20, and I'll just press apply and OK. Now, as I told you in the morning session as well, to implement and simulate anything in this particular tool, or to get an output or result of anything or everything, I will need this sync block. This is important here. This sync block, from this particular sync block library, I will use this particular block, instantaneous entity counting scope. Now, if you maneuver over this, it will show that what this block will do. Okay, I just put the cursor on this particular button, it showed that it will display the entity count versus the time. And in the same way, there are various kinds of sync blocks that we can use here. As we can see here, this particular sync block basically performs, it displays continuous stair or stem plots of an attribute versus time or index. And in the same way, this is your another sync block that we show what this block does. This block works that it write discrete event input signal or specific array or structure in base workspace. So in this way, you have got many types of blocks, and all these sync blocks have their various functions. So I have chosen this one, entity instantaneous entity counting scope that displays the entity count versus time, and I have added this to my project. Okay, so this is a very basic structure. I want to run the simulation or implementation in real time for 200 iteration, 300 iteration. I could just press the value here, it will execute or it will run it for that many number of times. So I executed it for 200 iterations. I press the run button, and here it is, it's implementing. Uh, this is the initial output that we are obtaining. This is the initial output we are obtaining that, this shows the various number of incoming employees or customers that are coming into our railway station or any kind of office to process their request. Now, I will make it a bit more complicated now to implement a more real life scenario. I want queue of customers, isn't it? Because my railway station or my airport, anything that will obviously contain a queue. So I will go to this Simulink library. I will open this queues option. When I click this queue option, what's that person? Yeah. Uh, so when I open this particular queue option, it shows me three options. First is my FIFO queue, and after this, I have my LIFO queue, and then I have my priority queue. Let's see what these queues does. FIFO queue store entities in, first out uh, sequence for an under determined length of time. The capacity parameter is the number of entities the queue can hold. Okay, then we have your LIFO queue. What this does, this stores entities in last in first out sequence for an undetermined length of time. The capacity parameter is the number of entities that the queue can actually hold. And then we move to our last queue structure, that is priority queue. What this does, this stores entities in sorted sequence for an undetermined length of time. The capacity parameter is the number of entities the queue can hold. The queue slots entities according to the values of the specified attribute in either ascending or descending order. So basically, what I want to show you here, dear faculty, is that it contains all kind of queue. I need FIFO. I will just right click on this, and it shows me that add block to our particular model structure. I edit it, and here it comes. Here it is appearing. Now I have got a queue. Okay. Now to process this queue, I need servers, isn't it? I need servers. Suppose I am in an office or I am at a railway station, at a airport. There has to be a ticket counter for that, and for that I need servers. So I'll just again go to my Simulink library. I will click on servers, and again it shows me various options, and I can choose any kind of options. First is my infinite server, then is my n server, then it has my single server. Now, since I'm implementing big data analytics in real time, I would not want a single server, because if I choose a single server, the amount of data will be very less. And that is not an ideal scenario for my big data analytics. So, and I cannot use an infinite server, because if I'm choosing an infinite server, then the value will go to infinity. And that also is not an ideal scenario for my big data analytics. So what I will do, I will choose n server. Now here it shows n. What is the value of n? Let me just add this first. I have added this particular block. Now this block will be shown in my project. Here it is. This is my answer. Now my job is not done. I have just added them. Now I have to edit their parameters to make them work. And to add their parameters again, I don't have to write blocks of codes. No, I'll just open it, double clicking it, it opens its parameters. It's asking me for FIFOQ capacity, means how many passengers or how many customers or how many employees my queue can contain at a time. Let's say we say it 5. Okay, that is my queue constraint presently is 5, and then it has statistics. Now this is important. It shows 5 parameters. It means we can obtain output for any of these 5 parameters. We can obtain output for number of entities departed. We can obtain the output for number of entities in the queue. We can calculate the average wait time of a particular passenger. We can calculate average queue length. We can calculate the number of entities. Okay, so I can choose any parameter. I'll choose average wait time. Suppose I want to calculate what is the average wait time of a particular passenger in a big airport or a big railway station. And as you can see here, as we are progressing with this, we are handling data manually according to our own wish, and there is there is no execution time, because if you are writing a code, I will show you this particular project implemented in Python, and you will see that how much execution time it takes. But this particular tool, this will not take any execution time at all. This is completely latency free, and it will have almost zero latency. So I want to calculate average weight here, and I have put my queue capacity to 5. I'll click apply and I'll press OK. So here I have implemented FIFOQ. Now we go to the server. It is my n server. Now what is the value of n? Here it again shows me an option. I can use 5 server, 50 servers, 500, 5,000, 50,000, 5 lakhs, 50 lakhs, whatever. Okay, so this can be implemented for any amount of data. Suppose I do this particular thing. I put the queue capacity as 50,000 and I put the server as 5 lakh. So just imagine the amount of data that will be produced from this particular system. It will be huge. And this particular tool will handle that all that data very efficiently without any delay or latency. So just to keep it simple, just to make you understand initially, let's keep the server to 5. Suppose I want my servers or my ticket counters to be constrained to 5. And another parameter is here, that is service time. That is how much time I want to spend on a particular passenger. That is, if a passenger is standing on a ticket counter, how much time or expected time that I want to allot to a particular passenger, that in that specific time the ticket can be allotted or granted to that particular passenger or the customer. So let's say I want 40 seconds for that. I'll put 40 here. I'll just press OK. Okay, again, it has many parts. Again, it has statistics. Okay, so I can again alter it, modify it according to my own wish and according to my own comfort. Let's press apply because I have used 5 servers. 40 is my time. Let's press apply and let's press OK. Now I will have to join them, connect them to make them work. I'll join this from this. Now here you see my FIFOQ it has two parameters. This is basically a substitute of coding that you can implement for your big data analytics. Either you code them out or you can use these GUI blocks. Uh, Let me just show you another aspect. Let's say I have not chosen average waiting time, okay, and I'll press just here apply, and I'll just press OK here, okay. Now see, it's showing only one output port. This FIFOQ is only showing only one output port, and I could simply, you know, make this like this, and these two ports will be joined, and I could try to see some output, but it will not calculate any output. Why? Why it will not calculate any output? Because in the queue, I have not chosen any parameters to calculate. What it will, you know, find out? It will find out nothing because I have not chosen. Just a second. What is this? Yeah, I have not specified any parameters to evaluate. So once I click on average wait time, for example, I want to calculate average wait time, and I press apply and I press OK. Now it will show another port here with name wait time. Okay, this is another port. Now question arises that where should I merge this particular port with, because this is already entitled with this particular port. This port, where should I join this? I told you, dear faculties, earlier as well, that in this particular tool, if I want to get any kind of output, I want scope, I want sync. So this particular port will also need a sync. So I'll just again go back to my Simulink library. I will go to syncs, and I will choose a signal scope here. Add to this block. This is my signal scope. Again, this is basically to obtain the output, and I have connected this. And when I open this particular thing, it will not show anything because my simulation or my implementation have not run. The program is not executed. So let me just execute it by pressing this particular button. Fine. Okay, we've got two outputs here. Our output number one is the same that I showed to you earlier. These are my number of customers that are coming in with instance of time. I implemented it for 20 customers. You can implement it for 20,000 customers. And that will be a huge amount of data. And this tool will handle that huge amount of data with zero latency and with a very fast processing speed. So this is our output one. We got another output here that we wanted to achieve. This is my average waiting time per customer. Okay, as you can see here, along with the time, as the number of customers are increasing, my average waiting time is increasing as well. Initially, the servers were operating very well. They were processing the incoming passengers or incoming employees very well. But as the queue increased, as the load increased on the servers, the average waiting time is also increasing. As you can see, it's going up and up as the time increases. So this particular output shows the implementation of our work, that yes, the average waiting time is also increasing with passage of time. Now, just like we have calculated average waiting time, we could have calculated any of these parameters. Any of these parameters we could have found out by just selecting that particular option. Now, this is still not enough. This is the implementation of a railway station or any other uh, incoming passenger system by using this graphical user interface tool, Simulink. Now I want to make it more re- real life scenario. What I want to do, I want to inculcate some attributes into this. Attributes like passengers are coming in, how much time that a passenger spends to, calculate and to obtain a particular ticket, or how much patience a passenger have. So these are kind of attributes that are used in my sentiment analysis, like patience of a passenger, patience, or you know mood of a employee. Suppose I'm trying to implement sentiment analysis on Flipkart, on Amazon. So since I am implementing sentiment analysis, I have to model or implement the mood of a user, that whether a user likes a particular product, whether a user dislikes a particular product. So implementing the mood of a particular user is very much important in sentiment analysis. So I'll show you how to implement like the mood of a customer or mood of a patient using this particular tool. Since the sentiment analysis is a major part of big data analytics, so we will be seeing that how to implement the attributes of a particular employee or a particular customers. So again, it has in its inbuilt library attribute section. Here it is, as you can see, attributes. I'll just open this up. It shows me three options. Let me see them one by one before I use any one of them. First one is attribute function. Then we have get attribute function. Attribute function is basic simulant attribute function to model any kind of attribute. Then we have get attribute function. It shows output attribute values to signal port for each departing entity. An attribute is numeric data attached to an entity. Each entity attribute has a unique name. Select from the list of available attributes or manually specify manually specify the attribute names. Available attributes are previously formed attributes that might exist on the incoming entity. So you just have to put your mouse on a particular entity, it will show that what particular attribute is doing. And then we have our third entity here, that is the set attribute. Set attribute values on each departing entity. An attribute is numeric data attached to an entity. Each entity attribute has a unique name. Select from a list of available attributes or create a new attribute. It is saying that we can either select from a list of attributes or we can create our new attribute as well. For example, if I am implementing a sentiment analysis concept and I want to, implement, say, whether a particular user is happy with the product, very happy with the product, okay with the product, or is annoyed with the product. All these attributes can be applied and implemented using this set attribute function. So I'll just open this up and add this to the block. Here is my set attribute function. I'll just remove this link and I'll just place it here. Just a second, please. Just give me a second. Okay, fine. So I have introduced this particular attribute, that is set attribute. Again, I have to model its parameters. I'll just double click it. Now here I can add any kind of attribute like sad, happy, annoyed, or you know, sponsored, whatever I want to do. And this particular thing is very useful for sentiment analysis in big data and data analytics. So what I will do, I will say I want to see that how much patience does a passenger have. So I will write patience here, and I want to add another attribute, that is ticket time. Ticket time means how much time uh, does a passenger takes to ask for a particular railway station or airport ticket, and I need its input to be from a signal port. So I'll choose this, and I'll just use apply, and I'll just press OK. So here in the set attribute section, you can see this is the port for my ticket time above that attribute that I have created, and this is the input port. Now, what I will do here is I will just first connect this to this one. I'll just make a bit of space here. Again, as I told you earlier, that in this particular tool, Simulink, if I need to get an output of anything, I need the scope. I need the sync, because syncs are used to get outputs. Again, I will click on the syncs. Here, since I'm using attributes, so I will use attribute scope here. I will just right click it and add it to my model structure. Here it is, attribute scope. I'll just join this with this particular thing. I'll open its properties. Presently, the scope is showing no output. Why it's showing no output? Because I have not executed the simulation. Now, there's a question here, a very important one, that this particular set attribute has a parameter ticket time. It is how much time it takes for a passenger to obtain a particular ticket. This time will be a random function. Okay, this time will be a random function. So from where does I get the random entries into this time? This is the question. From where does I obtain or get the random entries in this function? So for that, I need to generate random numbers. Okay, so to generate random numbers, I will go to my block. I will go to generator. I will go to signal generators, and here it is event-based random number generator. Okay, this particular thing generate random numbers from the specified distribution parameters and initial seed. I will just right click this and add it to my model, and I'll just open this up. I'll just put it here, and I'll just feed the random numbers into this set attributes. Now again, I'll have to model this out. I just double clicked it. Again, I want it to be uniform. Minimum value, say, I want to start from 20 passengers and I want to go until 60 passengers. Now, here, notice this. Its initial seed means the initial starting number. Say it's 1, 2, 3, 4, 5. Okay. Notice this. Present. For now, I am just aborting this. I'm not saving the alterations. I am just aborting this like this. I have aborted it. Now, we have another option here. Not this one. This one. Yeah. This was our time-based entity generator, which used to generate the incoming passengers. When I double-clicked it and I see in its properties, it is also showing initial seed of 1, 2, 3, 4, 5. Please keep track that initial seeds cannot be the same for any two blocks. Here it is 1, 2, 3, 4, 5. Okay, I am fine with it. But here in the random number generator, I have chosen uniform. I had chosen 20. I had chosen 60. Initial seed is a problem here. I again don't want it to be the same. So what I will do, I will start it from 2, 2, 3, 4, 5, 6. That is different from the other initial seed that is 1, 2, 3, 4, 5. Now I will click apply and now I'll press OK and I'll just connect this to this. This is my complete model structure. I will just execute it, implement it. It's showing me something. The entity. Okay, fine. I skipped something. I skipped something. Uh, this is my attribute scope. Now, I told you that we have to model everything here. I did not model my attribute scope. I will right click this thing. I'll go to block parameters of this scope. Here in the Y attribute name, it is showing count. Now we don't have any parameter with the name count. We have parameter with the name ticket time. So I will just put T here and it has automatically showed me ticket time. That is the parameter that I needed. I'll choose this. Now here I can also choose the type of output that I need, whether I need a stair or a stem or a continuous output. Let's choose stem here. Press apply and I'll press OK. Let's hope this time it runs. Let's try it. Now it's executing perfectly. It's showing three outputs now. Why it's showing three outputs? Because you see I have three scope here, three sinks here. That's why it's showing me three outputs. Output number one is my initial output that I showed earlier to you. That shows my incoming passengers that are coming in with time. Let's close this output. We have seen it. Output number two is my average waiting time that we earlier obtained. Let's close this one. And my output number one is my third output that we have just calculated it for the average time that customers take, that a particular passenger take. That is the ticket time that a passenger takes to get its ticket. And as you can see, the ticket time is very much variable, and this is what we wanted. And it is executing till 200 iterations, since we have implemented it for 200 iterations. So let me just reiterate this particular thing, what we have done. Initially, we choose a time-based entity generator, a time-based entity generator. We opened it. We structure it according to our requirements. That is, minimum is 0, maximum customers I want is 20, and I want uniform distribution. I said it's okay. Now to just catch it output, I used a sync or a scope in this tool to catch output of any particular entity or any particular input. I need a sync or a scope. So this is my sync or this is my scope that I added from Simulink library. It is showing me the output like this. Why it is showing me the output now? Because I have run the simulation. Earlier it was showing me blank or empty. Now from these two blocks, I wanted to build more on these blocks. So I added a queue here. This is my FIF queue. I could choose any kind of queue from my Simulink library. Let's see here. Let's go to the queues once more. Here are queues. It shows me three options. I can choose any queue. So I chose queue here, and after that I chose server here. Okay, and in the queue I wanted to calculate average waiting time of a customer. So I opened its properties. I said that the capacity of my queue will be 5 customers. And in the statistics part, I chose average waiting time that I wanted to calculate. And I pressed OK. And again, since I'm calculating something, I need a sync or a scope to catch its input. So this is the scope that I attached to its to this to catch it in its input, and I obtained this output number two. Then, after obtaining output number two, what we did, we further constructed on this model, and we said that since we are dealing with big data analytics and attributes are a major part of big data analytics, I need to model or I need to structure the attributes as well. Attributes of a human being, attributes of a customer, attributes of an employee. I can model anything. So to that, I again went to my Simulink library. I went to the attribute section. Here it is. And I chose set attribute function. And I imported this particular set attribute function to my model. This is my model. And after importing this set attribute, I went to its properties. I chose the first parameter as the patience. I can choose it by anything. And then I chose the second parameter as ticket time. And I put its input from a signal port and I pressed OK. Now, since the ticket time will be random, so I needed to generate random numbers here. So I feeded this with a event-based random number generator. From where did I obtain this block? I obtained this block from here. Uh, I went to this generator block, signal generators. Here it shows me event-based random generator. Other option is event-based sequence generator. I did not want it sequence generator. I wanted a random number generator. So I chose this. And after choosing this, I fed its output into its input. And after constructing this entire structure, I press the implementation button, and again it's again showing me the desired output. See here, it's showing me the average waiting time. It's showing me the number of customers coming in, and it's also showing me, here it is, the average ticket time that a customer takes. So in this way, you can tweak it, change it according to your wish or according to your need, and you can change it for any large amount of data. Okay, now let me show you the comparison here. I have also modeled a very similar project like this in Python as well. Let me open this up. This is the Python code for a similar kind of program. It comprises of two files. Your file number one is this, and your file number two is your this. This is a file number two. As you can see, how much code I have to write here. How much code I have to write, and let's execute this code. Let me run this. It will take time. It will take a lot of time. See, this is the execution time. This is the latency that I talked about, and it has possibilities of errors as well. And when I implemented the same thing using this graphical user interface tool, how much time it's consuming? It's consuming a maximum of 1 to 2 seconds. That's it. So you can see the advantages of this particular tool in big data and big data analytics. You can manually change the data according to your wish. it's still executing, still it's not obtaining the output. The code that I implemented in Python, it's still executing. And so, as you can see, the improvements or the advantages of using this particular tool. So if any of you faculties wants to implement this tool, I have opened this window. You can implement it now, and you can ask me for any kind of help or issues that you face during your implementation. Ma'am, are you there? Ma'am, are you there? Geeta, ma'am?
Sir,
Yes,
sir,
ma'am. Yeah. So shall we wait for 5 minutes for the faculties to implement it, or shall we continue?
okay, sir. We will give a 5 minutes break, sir.
Okay, so I have opened this window, and we shall wait for 5 odd minutes. And I hope that the faculties are implementing it. And if any one of you face any problems, I am here online. You can ask me, and then we will continue. Okay, fine. We shall now resume our session. If any of the faculty member is having any issue in this particular implementation, I will share my email ID with ma'am. You can contact me later as well. I will assist you shortly. So presently we will cover some more content on big data analytics using Hadoop now. Again, I am reiterating this. If any of the faculty member is having any issue in implementing this, I will share my contact and email ID with ma'am. You can contact me anytime. I shall support you. Now, we should move ahead and we should move. So, until now, what we have done, we have studied in the morning some introduction about what is big data analytics and how big data works. And after studying that, we implemented some hands-on practice on this novel tool, and that is a graphical user interface tool. By using I can implement big data. Now we will shift our focus to part number 2 of our session. Some part of this session will be covered by 4 p.m. today, and some part of this particular session will be covered in our next class that will be on next month. So it's basically using Hadoop and its architectures. And during this, we will do some hand-on practice on some big data analytics tools like Data Wrapper, Hadoop Apache, and MongoDB. But first of all, I will have to introduce some concepts and some very crucial basics about Hadoop. So let me just start by them. Okay, fine. Hadoop architecture that we have now, it will contain some common Hadoop shell commands, anatomy of file, write and read. Hadoop is a major component of your big data and big data analytics and real-time implementation of big data. So we will be studying that. Before that, I want to just explain you one more thing before going to Hadoop. Before going to Hadoop, I would like to explain you one more thing here. Yes. So sentiment analysis that I told you is a major part in big data analytics. So how could we model sentiment analysis? Let me just show you something here. This is my Flipkart, okay, online shopping site, or just let's say I will just open YouTube here. Flipkart, YouTube, or whatever website you open. Let's open Amazon as well. Amazon. So let me open any specific product on Amazon. Let me open, suppose refrigerators here. Refrigerators I have opened. I want to buy this one. I have opened this one, and when I scroll down, there are customer reviews here. Oh, in this one, there are no customer reviews. Let me open another entity. Let me open some mobile phones to show you something here. I want to buy, say, this particular phone, and when I scroll it down, Yeah, here we are. Here we are. There are some customer reviews here. Okay, uh, some are assigning it with 1 star. Some are assigning this particular phone with 3 stars. Some are assigning with it 4 stars. Some are assigning with 5 star. Okay, and the same goes with the YouTube. When you open your YouTube window, or even your Facebook window, it will show you the page of your interest or the videos of your interest. How does it happen? It basically happen by using a big data analytics tool, that is sentiment analysis. The YouTube or Amazon or say Flipkart or Facebook analysis your past searches, form a sentiment based on that, and based on your past search it recommends you some future videos, and that particular phenomena is called sentiment analysis. Okay, so what we can do here, what I want to explain you here, how we can implement sentiment analysis. Right click on a page, view page source. This is the page source. Okay, so either from here you can get the sentiments about a particular product. This is the page source. Here you will get all the data about a particular product. Now how to extract the sentiments from this page source is can be done by using a Python code.
Call sir. Call sir. சார் வாங்க.
Hello, am I audible to you? Hello, am I audible to you?
Yes, sir.
Yes.
Yes, sir.
Okay, fine. So I shall continue. So what I was saying to you that what we can do from here, we can catch the sentiments or the reviews of a particular customer from here, and we can store it in Excel file, something like this, something like this. Something like this. I imported this particular information from Amazon, and as you can see, all these reviews or sentiments are being stored in an Excel file. And what I will do, I will feed this Excel file into my code. Here it is the code. I will feed this Excel file into this code. And I'll just execute this particular file here. So these are the outputs that we are obtaining from that particular code or that particular sentiment analysis. As we can see, this output is from one of my research papers. As we can see here, we obtained 4 outputs here. My output number 1 is showing sentiment analysis of online consumers and sentiment analysis with increasing product features. Okay, that is as the features of a particular as the features of a particular product
ମୁଁ ଖାଲି
increases.
ଏଇଟା ଲଗେଇଦେବି, ବୁଝିପାରିଲୁ ପୁଅ, ଆଉ କିଛି କରିବିନି, ସବୁ ତକ ସାରିଦେବି ଆଜି। ତମେ ଆଉ ଢୋଟିବ ଯେ ପୁଅ କରିବ।
Yeah,
କୁଆଡେ ଗଲା ତୋର ସେ ମାମ୍ବା?
yeah, some voice is coming from the background.
ଜମା ନେବିନି ଏ ସବୁ।
ଦାଦା କହୁଛନ୍ତି କି ତମକୁ ନେବେନି ଯେ
Some voice is coming from the background.
Sir, now you can be muted, sir. You can continue.
Okay, so what I was saying that as the product feature increases, the positive sentiments about a product for the consumers also increases. There is a linear, directly proportional relationship between the two. And then we move from to our output number two, that is negative online reviews. As you can see that with the increasing negative online reviews, the sentiment analysis also goes down. Okay, and this is exactly the structure or the phenomena we expect. Then we move to our output number three. Here it is: positive online review score versus the sentiment analysis. As I just explained you, it's a directly proportional relationship. And in our output number four, it is showing negative reviews with the sentiment analysis. As you can see that along with the increment of the negative reviews, the sentiment analysis is also decreasing. So this is the code that I wrote, and I linked that code with some Excel data imported from Amazon website. And based on that particular imported data or information from Amazon, I calculated the sentiment analysis of the users. So what this particular thing shows that uh, in this entire process, here is the page source. If I want to know, or if I want the customer or the user review score of say Amazon.com, I have two options. I just go to its backend data and I extract it by applying Python or MATLAB code, or I can straight away email Amazon.in and request them to provide us their user review score. But they don't, they won't allow us to have an access to that in free. They take some amount for that, and that is not a wise option to do. So the best option is just to go to the back end and just take some user review score from this data using Python or MATLAB code. I have the code. I will share that code with ma'am. You can take that code from ma'am and use it for your own work as well. And by extracting the data to MS Excel, you can actually implement the sentiment analysis. So this is what I wanted to explain you about sentiment analysis. It's a wonderful thing. I I recently saw a paper in IEEE transactions. What they had done, they picked the trending area on COVID-19, and they mapped or they measured the sentiments of the people from a specific state of China on COVID-19, that how people are feeling. Are they under panic, or are they happy, or are they normal? They just analyzed the sentiments of the people of a particular state in China using sentiment analysis, and they published that paper in IEEE transactions. It's one of the highest research credentials that we can have. So you can see that how important and how crucial this tool can be, and of course you can use it in your research as well. So now let's coming back to the facet number 2 of our session, that is Hadoop. Now we'll study some concept about Hadoop, and after studying that we will do some hands-on practices on some Hadoop and big data analysis tool, once again like Hadoop Apache or data wrapper, MongoDB, these kind of tools. Let me just start now. Common Hadoop shell commands. Hadoop SDFS is a distributed file system which provides redundant storage space for files having huge sizes. It is used for storing files which are in range of terabytes to petabytes. To learn more about world's most reliable storage layer, follow this SDFS. Let's continue with Hadoop SDFS commands. This is Hadoop architecture. This particular slide shows some of the commonly used Hadoop commands that we can use. SDFS command to check the health of Hadoop file system. This particular command can be used to check the health of a Hadoop file system, that is HDFS fsck/. These are some of the common Hadoop shell commands that we can use. First is the path. Start checking from this path. Then we have delete, that is to delete the corrupted files. Then we have files, that is to print out files being checked. Then we have files/blocks, that is to take the printout and to print the block report. Then we have files, block, and locations to print the locations for every block. Then we have file, block, and regs to print the network topology for data node locations. Then we have files, block, replica details to print each replica details. Then we have files, block, upgrade domains to print upgrade domains for every block. Then we have include snapshots. These are all commands that we use in our big data Hadoop. Then we have include snapshots, that is to include snapshot data if the provided path indicates a snapshotable directory. Then we have list corrupted file blocks. It shows print the list of missing blocks and files they belong to. Then we have open for write. It shows print out files open for write. Then we have show progress, print out dots for progress in output. And then we have storage policies. It shows print the storage policy summary for the blocks. Then we have maintenance. Maintenance is basically used to print the maintenance state node details. Then we have block ID to print the information about the block. These are some of the structures that we use. Common Hadoop shell commands, that is get configuration. I'll share this PPT. These are basic commands that we use in Hadoop for name nodes, for second name nodes, backup nodes, general nodes, include file, exclude file, config key, etc. And then we move forward into our structure. Name nodes, it gets the list of name nodes in the cluster. Then we have secondary name nodes. It gets the list of secondary name nodes in the cluster. Then we have backup nodes, gets the list of backup nodes in the cluster. Then we have the include files, gets the include file path that specifies the data nodes that can join the cluster. Then we have exclude file, gets the exclude file path that specifies the data nodes that need to be decommissioned. And then we have NNRPC address, gets the name node RPC address. And at last we have config key. It shows that it obtains a specific key from a specific configuration. Now we'll move ahead. Yeah. Then we'll move forward into our structure. These are some of the common Hadoop shell statements that we can use. We'll just explain them one by one. Uh, just a second. Yeah. I have already explained you these statements earlier. So these are basically some of the commands or the statements that we use in Hadoop. What I will do, dear faculties, I will share this PPT with ma'am, and so that you can also use these statements or commands for your work. Then we move on to our next PPT. Yeah. This PPT is about MapReduce. As I told you in the earlier session in the morning, that MapReduce is an important feature of Hadoop, the MapReduce programming. MapReduce is a programming structure that was designed to allow parallel distributed processing of large data sets, converting them to sets, and then combining and reducing those tuples into smaller set of tuples. In layman's terms, MapReduce was designed to take big data and use parallel distributed computing to turn big data into small or regular sized information. As I told you in the morning as well, dear faculties, that there are basically two types of structures we have in our big data analytics. One is our structured data. The structured data is the one that is already in the form of tables, rows, and columns. That particular structured information is very, it's very advantageous for us. It is no issue for us. But when we have our type number two, that is unstructured data, then there is a problem, because we cannot apply any big data analytic tool on an unstructured information. So to convert that unstructured information into proper structured data with rows and tables, this map reduced tool is efficiently used. The parallel distributed processing refers to a powerful framework where mass volumes of data are processed very quickly by distributing processing tasks across clusters of commodity servers. With respect to MapReduce, tuples refer to key value pairs by which data is grouped, sorted, and then processed. MapReduce jobs work via map and reduce process operation sequences across a distributed set of servers. In the map task, you specify your data to key value pairs, transform it, and then finally filter it. Then you assign the particular data to nodes for processing. In the reduce task, you aggregate the data to smaller size structures. Data from the reduce step is transformed into standard key value format, where the key acts as the record identifier and the value is the value that's being identified by the key. The clusters computing nodes process the map and reduce the tasks that are defined by the user. This work is done in accordance with the following two steps. First step is map the data. That is important. The incoming data must first be delegated into key value pairs and divided into fragments, which are then assigned to map tasks. Each computing cluster, a group of nodes that are connected to each other and perform a shared computing task, is assigned a number of map tasks, which are subsequently distributed among its nodes. Upon processing of the key value pairs, intermediate key value pairs are generated, and finally the intermediate key value pairs are sorted by the key values, and this list is divided into new set of fragments. Where whatever count you have for these new fragments, Just a second. Whatever count you have for these fragments, it will be the same as the number of reduced tasks. Then we move further into this. Step number 2 is your reducing step, that is reduce the data. Every reduced task has a fragment assigned to it. The reduced task simply processes the fragment and produces an output, which is also a key value pair. Reduced tasks are also distributed among the various nodes of the cluster. After the task is completed, the final output is written onto the file system. The huge volume, velocity, and variety, since these three are the basic pillars of our big data analytics, so we will be structuring according to these particular parameters. It says that a huge amount of volume, velocity, and variety of data by using map and reduce tasks to tag your key value pairs, and then reduce those pairs into smaller sets of data through aggregation operations that combine multiple values from a data set into a single value. A diagram of MapReduce architecture is shown here. This basically shows the architecture of this particular operation. Before explaining this, I will study this particular thing. Yeah, this is the architecture here. As you could see that huge volumes of data are first mapped. They are then, shuffled, and after shuffling, they are being reduced to a structured table or rows forms. And this is basically the operation that our MapReduce performs. Then we move ahead. If you are using MapReduce as a part of a Hadoop solution, then the final output is written onto the Hadoop distributed file system, that is HDFS. HDFS is, as I explained you earlier in the morning as well, that HDFS is also a part of Hadoop. MapReduce, HDFS, Yarn, these are basic components of Hadoop. So we will be studying them from starting to end, and after completing that, we will be doing some hands-on practice as well on some Hadoop or big data analytics real-time tools. One we have already studied, that is Simulink. It was a real-time big data analytics tool. I explained that to you, and we did some hands-on practice on that. And apart from that particular tool, we will be studying two more real-time, analytics tools, and we will be doing some hand-on on those tools as well. So let's continue with this. HDFS is a file system that includes clusters of commodity servers that are used to store big data. HDFS makes big data handling and storage financially feasible by distributing storage tasks across clusters of key commodity servers. The Hadoop MapReduce framework creates a map task to process each input split. The map task performs the following functions. It first uses the input format to fetch the input locally to create input key value pairs. It applies the jobs supplied map function to each key value pair. It performs the local sorting and aggregation of results. If the job includes a combiner, runs the combiner for further aggregation, and it stores the results locally in memory and on the local file system. It communicates the progress and the status to the task tracker. Map task results undergo a local sort by key to prepare the data for consumption by reduced tasks. If a combiner is configured for the job, it also runs in the map task. A combiner consolidates the data on an application specific way. reducing the amount of data that must be transferred to reduce tasks. For example, a combiner might compute a local maximum value for a key and discard the rest of the values. The details of how map tasks manage, sort, and shuffle the results are not specified here. That I will explain you later. The reduced phase aggregates the results from the map phase into the final output. Usually the final output set is smaller than the input set, but this is basically dependent on the application that we are using. The reduction is specified by parallel reduced tasks. The reduce input keys and values need not have the same type as the input keys as the output keys and the values. The reduce phase is optional. You may configure a job to stop after the map phase completes. Reduce is carried out in three specific phases, that is copy, sort, and merge. A reduce task basically fetches the job resources locally, enters the copy phase to fetch local copies of all the assigned map results from the map worker nodes. When the copy phase completes, executes the sort phase to merge the copied output into a single sorted set of key value list pairs. When the sort phase completes, executes the reduce phase, invoking the job supported reduce function on each key value pair list. And it also saves the final output to the output destinations like HDFS, that is the file system. The input to a reduce function is the key value pairs, where the value is a list of values sharing the same key. For example, if one map task produces a key value pair and another map task produces the another key value pair named EAT1, then those pairs are consolidated into EAT2, 1, means they are combined or merged into one for input to the reduce function. We then move forward. If the purpose of the reduce phase is to compute the sum of all the values for each key, then the final output key value pair for this output is EAT3, quite understandably. So MapReduce job to Hadoop. What this particular MapReduce do to Hadoop? The local job client prepares the jobs for submission and hands it off to the job tracker. The job tracker then schedules the job and it distributes the map work among the task trackers for parallel processing. Each task tracker spawns a map task. The job tracker receives the progress information from the task trackers. As map results become available, the job tracker distributes the reduce work among the task trackers for parallel processing. Each task tracker spawns a reduced task to perform the work. The job tracker receives progress information from the task trackers. Now, what is the job or what is the task of a job tracker? We'll explain it here. The job tracker is responsible for scheduling the jobs, dividing a job into map and reduce tasks, and distributing map and reduce tasks among worker nodes, task failure recovery, and tracking the status of a particular job. Job scheduling and failure recovery are not discussed here. That we'll see later because they are not directly associated with big data analytics. Then we move forward. When preparing to run a job, the job tracker fetches input splits from the shared location where the job client placed the information, creates a map task for each split, assigns each map task to a task tracker. The job tracker monitors the health of task trackers and the progress of the job. A map task completes the output. Uh, a, a map task is completed and the outputs becomes available. The job tracker basically creates reduce tasks up to the maximum enabled by the job configuration, assigns each map output partition to a particular reduced task, and it finally assigns each reduced task to a task tracker. So these are basically the operations of a job tracker. Then we have the task tracker. A task tracker manages the task of one worker node and it reports the status of the job tracker. Often the task tracker runs on the associated worker node, but it is not required to be on the same host. When the job tracker assigns a map or reduced task to a task tracker, the task tracker fetches job resource locally, spawns a child JVM, that is Java virtual machine, on the worker node to execute the map or to reduce task, and then it reports the status of the job tracker. Then we have the cluster setup here. A Hadoop cluster is a special type of computational cluster designed specifically for sorting and analyzing huge amounts of unstructured data in a distributed computing environment. Such clusters run Hadoop's open source distributed processing software on low cost commodity computers. Typically, one machine in the cluster is designed as the name node, and another machine assigned as job tracker. These are the masters. The rest of the machines on the cluster act as both data node and the task tracker. These are the slaves. Hadoop clusters are often referred to as shared nothing system because the only thing that is shared between the nodes is the common network that joins them together. Then we move ahead in the cluster setup. Hadoop clusters are known for boosting the speed of data analytics applications. As I told you earlier as well, that Hadoop forms a basic part for data analytics and real-time data analytics. It is also reiterating the same thing, that is Hadoop clusters are known for boosting the speed of data analytics applications. They are highly scalable. If a cluster's processing power is overwhelmed by growing volumes of data, additional cluster nodes can be added to increase the throughput. Hadoop clusters also are highly resistant to failure because each piece of information and data is copied onto other cluster nodes, which ensures that the data is not lost if one of the node is failed. Now then we have SSH and Hadoop configurations. The Hadoop control scripts relies on SSH to perform cluster-wide operations. For example, there is a script for stopping and starting all the daemons in the cluster. Note that the control scripts are optional cluster-wide operations that can be performed by other mechanisms too, such as uh, uh, like we have distributed shell commands. To work seamlessly, SSH needs to be set up to allow passwordless login for the Hadoop user from the operating structures or the machines in the clusters. The simplest way to achieve this is to generate a public private key pair, and it will be shared across the entire cluster using NFS. And this is an example of how to do it. Again, it is also the same example at how a public-private key pair can be generated or formed, and it could be shared across the entire structure. These are some of the setting properties in configuration file. This again is a coding part. So this was basic about how we configure Hadoop, how we use Hadoop. Then we move ahead into our next PPT. Managing resources and applications with Hadoop Yarn. As I told you in the morning session, Yarn is another part of Hadoop. Yarn stands for yet another resource negotiator. It was introduced in Hadoop 2.0 to remove the bottleneck on job tracker, which was present in Hadoop 1.0. Yarn was described as redesigned resource manager at the time of its launching, but it has now evolved to be known as large-scale distributed operating system for big data processing. It's a kind of a large-scale distributed operating system that we use in our big data. Managing resources and applications with Hadoop Yarn. This was Hadoop 1.0 architecture. As we have here on the LHS, it is on the left-hand side, we have the clients. Then in the center, we have the job tracker to track and monitor the jobs. And then on the right-hand side, we have the task tracker that tracks the task and also performs the basic operation of mapping and reducing. Then its improved version was introduced in Hadoop 2.0. Yarn architecture basically separates resource management layer from the processing layer. In Hadoop 1.0 version, the responsibility of the job tracker is split between the resource manager and the application manager. As you can see here, we have here a resource manager, we have here a distributed file system, and we have placed a MapReduce function at the top to perform the mapping and reducing operations. Yarn also allows various data processing engines like graph processing, interactive processing, stream processing, as well as batch processing to run and process data stored in HDFS. That is the basic Hadoop file system, thus making the system much more efficient. Quite understandably here, because it allows various kinds of structures, systems, or engines like graph processing, interactive processing, stream processing that we use for our live feed, as well as the batch processing. All these structures can be implemented on this particular operating system, which makes it very efficient and very smooth to use. Through its various components, it can dynamically allocate various resources and schedule the application processing. For large volume data processing, it is quite necessary to manage the available resources properly so that every application can leverage them. Then we have some of the basic features of Yarn. Yarn gained popularity because of the following applications. We have scalability here. The scheduler in the resource manager of Yarn architecture allows Hadoop to extend and manage thousands of nodes and clusters. Of course, it is very much scalable. We can extend it for thousands or even 10,000s of cluster and nodes. Then we have compatibility. Yarn supports the existing MapReduce applications without disruptions, thus making it compatible with Hadoop 1.0 as well. quite understandably so, because it cannot be the way that after the introduction of Hadoop 2.0, I cannot use this operating system with Hadoop 1.0. So it allows the proper compatibility with Hadoop 2.0 as well as Hadoop 1.0. Then we have the cluster utilization. Since Yarn supports dynamic utilization of clusters in Hadoop, which enables optimized cluster utilization. Then we have multi-tenancy. It allows multiple engine access, thus assessing organizations a advantage of multi-tenancy. And then we just move forward to its architecture, the basic Hadoop Yarn architecture, how the basic Hadoop architecture works. I explained it earlier as well. On the LHS, we have clients, and on the RHS, we have node manager. Then we have the basic components of Yarn. Component number one is client. It submits map-reduced jobs. And then we have the resource manager. It is the master daemon of Yarn and is responsible for resource assignment and management among all the applications. Whenever it receives a processing request, it forwards it to the corresponding node manager and allocates the resources for the completion of the particular request accordingly. Then we move forward. The major components of Yarn. Component number one is a scheduler. It performs scheduling based on the allocated application and available resources. It is a pure scheduler, means that it does not perform other tasks like monitoring or tracking, and does not guarantee a restart if a particular task fails. The Yarn schedulers supports plugins such as capacity scheduler and fair scheduler to partition the cluster resources. Then we move forward to application manager. It is responsible for accepting the application and negotiating the first container from the resource manager. It also restarts the application manager container if a particular task fails. Then we move on to the node manager. It takes care of individual node on a Hadoop cluster and manages applications and workflow and that particular node. Its primary job is to keep up with the node manager. It monitors resource usage, performs log management, and also kills a container based on the directions from the resource manager. It is also responsible for creating the container process and start it on the request of application master. Then we have that what is an application master is. What an application master is in Hadoop Yarn. So we'll see that what is an application master. An application is a single job submitted to a framework. The application manager is responsible for negotiating resources with the resource manager, tracking the status and monitoring the process of a single application. The application master requests the container from the node manager by sending a container launch context, that is CLC, which includes everything on the application that requires to be run. Once the application is started, it sends the entire health report to the resource manager from time to time. Then we have the container, that is what is a container. It is a container basically is a physical resource like RAM, CPU cores, and a disk on a single node. The containers are invoked by container launch context, that is CLC, which is a record that contains information such as environment variables, security token, and dependencies, etc. We have here now application workflow of a Hadoop yarn. As we can see in the workflow, the steps are specified by numbers from 1 to 8. In fact, from 1 to 7. First, individual client connects to a resource manager. The resource manager then connects to an application manager. The application manager first sends the acknowledgement message, and then it processes the request, and then the application manager goes to the node manager. Node manager goes back to the client, and then the resource manager also reports back to the client. So this is basically the application workflow of your Hadoop yarn. Clients, so this basically explains what I already explained to you in the previous image. Client deposits a particular application. The resource manager allocates a container to start the application manager. The application manager registers itself with the resource manager. The application manager negotiates containers from the resource manager. The application manager notifies the node manager to launch containers. Application code is executed in the container. Client contacts resource manager, application manager to see the application status. And finally, once the processing is complete, the application manager unregisters with the resource manager. So this was basically about yarn. Yarn is an important part of Hadoop. We have studied SDFS, we have studied yarn, and now we'll study the next part of Hadoop. I think, yeah, Hive. Hive is also an integral part here, so we'll study Hive as well. The basic Hadoop ecosystem component, Apache Hive, is an open source data warehouse system for querying and analyzing large data sets stored in Hadoop files. Hive completes three main functions, that is data summarization, query, and analysis. Hive uses language called HiveQL that is very much same as SQL, that is Hive query language. HiveQL automatically translates the SQL-like queries into MapReduce jobs, which will execute on Hadoop. Because HQL, raw SQL jobs, if I want to execute them on MapReduce or in Hadoop, it will not work. So it basically converts your SQL-like queries to HiveQL, and that will be executed on Hadoop. This is the structure of this particular operation. User basically submits the queries to Hive. Hive contains its own metadata. Hive converts the SQL into your Hive query language, which is then fed into a Hadoop cluster, which consists of a master and multiple slaves. So this is basically a structure or architecture of how your Hive operates or how your Hive works. Main parts of Hive are metastore. It stores the metadata. Driver manages the life cycle of a Hive query language statement. Query compiler compiles HiveQL into directed acyclic graph, that is DAG. Hive server provides a thrift interface, and JDBC or DBC server, that is the Java database connectivity server used for establishing, connections between two ends in core Java as well as advanced Java. So then we move to the next part, that is Pig. Apache Pig is a high-level language platform for analyzing and querying huge data sets that are stored in HDFS. Pig as a component of Hadoop ecosystem uses Pig Latin language. It is very much similar to SQL. It loads the data, applies the required files, and dumps the data in the required format. For program execution, Pig requires Java runtime environment. This is the structure and how it works. Pig Latin is used to express the data flows. Then we have your execution environment that goes to local execution in a single Java virtual machine. Then we have the pig script, pig Latin compiler, input file present in the HDFS. They both comes in the compiler for compilation of the tasks. And then finally, all the tasks are being executed in the PEP reduce job internally. So this is basically the architecture of how your pig works. Some more about pig, some features of pig. Feature number one is extensibility. For carrying out special purpose processing, users can create their own function. Optimizing opportunities. Pig allows the system to optimize automatic execution, and it allows the user to pay attention to semantics instead of efficiency, and it handles all kind of information and data that is both structured as well as unstructured, which is a big advantage. So this was about pig. It was a part of Hadoop, as I told you earlier, which will be used for big data real time, for big data analytics in real time. Then we move on to our next part. This is also important. Introduction to NoSQL and Hadoop. Now, we use structured query language, that is SQL, in our DBMS, but in Hadoop, that will not be used. Why? We will study it here. NoSQL, known as not only SQL database, provides a mechanism for storage and retrieval of data. And next generation database, it is a distributed architecture with MongoDB and is an open source. Most of the NoSQL are open source, and it has the capability of horizontal scalability, which means that commodity kind of machines could be added. The capacity of the clusters in NoSQL can be increased. It is a schema-free, and there is no requirement to design the tables and pushing the data onto it. NoSQL provides easy replication, claiming there are very less manual interventions in this. Once the replication is done, the system will automatically take care of followers. The crucial factor about NoSQL is that it can handle huge amount of data and can achieve performance by adding more machines to your clusters, and can be implemented on commodity hardware. Uh, there are close to 150 NoSQL databases in the market right now, which will make it difficult to choose that which NoSQL package is the best one for you. There are different kinds of data structured, unstructured, and semi-structured, and hence RDMS. So this particular slide basically specifies that why I need NoSQL. Why not, ordinary SQL can do the job for me. This specifies that why I need NoSQL. So there are many different kinds of data that are structured, unstructured, and semi-structured, and hence RDBMS are not designed to manage these types of data in an efficient way. NoSQL databases comes into the picture and are capable to handle all kinds of data. People today are using different kinds of methodology, and if you talk about the code velocity and implementation level, people wish to execute various activities at the same time. NoSQL is a non relational DBMS that allows that do not need a fixed schema, avoids joins, and is easy to scale. NoSQL database is used for distributed data stores with homogeneous data storage needs. NoSQL is used for big data and real-time web applications. For example, companies like Twitter, Facebook, Google that collect huge amount of information every day use NoSQL in their information aggregation. What is the key difference between SQL and NoSQL? SQL pronounced as SQL or CQL is basically a RDMS, whereas NoSQL is a non-relational or distributed database. SQL databases are table-based databases, whereas NoSQL databases can be a document-based key value pair or graph databases. SQL databases are vertically scalable, while NoSQL databases are horizontally scalable. SQL databases have a predefined schema, whereas NoSQL databases use a dynamic schema for unstructured data. SQL requires specialized database hardware for better performance, while NoSQL uses commodity hardware. These are the advantages of uh, NoSQL. So basically, dear faculties, up to now, what we have studied, let me just conclude this thing. We have studied various kinds of uh, big data analytics tools, its basic, how they work. We studied the introduction in the morning. Then in the afternoon session, we studied a big data analytics tool that is Simulink and how we can use it. I explained the tool to you. We did a we had completed a hands-on practice session on that particular big data analytics tool that can be operated in real time. And after that, we switched to facet number 2 of our session, that is NoSQL tool. And no, I mean that is Hadoop tool, Hadoop and its basic variants. I have covered few of the variants, and few are left, and that we will cover in our upcoming session that is, I think, scheduled in the upcoming month in 2021. So, and after that, we will be doing some hands-on practice on some more big data analytics and real-time applications like data wrapper, MongoDB, Apache server, Hadoop Apache. So these basic tools and these advanced tools, in fact, I could say that we will be doing some hands-on practices in the upcoming month, in the upcoming session, to just study more about Hadoop and big data analytics. So what I will do now, I will share all the contents with ma'am so that it could be useful for all of you as well who attended this particular session. And I have another thing to show to you here. Let me open this particular file. I told you in the morning, dear faculties, that artificial intelligence has many branches. Like it has machine learning, it has nature-inspired algorithms, it has deep learning, etc., etc. And let me just show you something here. This one. Yeah, this is the code. This code could easily be converted into Python as well. I told you in the morning that there is a artificial intelligence or machine learning algorithm that can be used in conjunction with big data analytic tool that is called biogeography based optimization, that is BBO. Okay, so this is the code for BBO. I wanted to explain this code to you, but unfortunately, today I won't be able to complete it because it will take a lot of time. Um, Once I could explain you this particular code, that how I have to, implemented and altered the traditional BBO to suit the requirements of big data and big data analytics, it would have been very useful for you. This is your BBO. So what I will be doing, I will be explaining this particular concept in our upcoming session, that how could we use or how could we tweak the basic artificial intelligence algorithms or operations to our big data requirements. So this is what I wanted to show to you. If any of you have any issues or have any confusion regarding what I explained to you, what I taught you today, you can ask me now. I shall answer them. Yes, I still, if any of you have any doubts or any issues, you can contact me on my email ID. And now I hand it over to ma'am.
Participants, if you have any queries, kindly ask. If no queries, I think shall we conclude the session?
Okay, ma'am. Sure.
Okay, sir. Um, Today our resource person Ajay Kaushik sir have covered the topic of basics and characteristics of big data analytics and big data tools for real-time applications and various tools for real-time applications like Hadoop Yarn and Apache Hive and next the difference between the SQL and NoSQL and Simulink. This I have clearly explained about the Simulink. So, and I have to thank our resource person for accepting us invitation on behalf of Computer Science Department, Excel Engineering College. Thank you, sir.
Thank you very much, ma'am. It was a
And
pleasure here. And I thank you and all the faculty members for being a part of this presentation. I'm
yes,
really thankful to all of them.
okay, sir. Thank you, sir. Kind request to the participants. Feedback link is given in the chat box. I request the participants to fill the feedback without fail. And also, I thank the participants to conduct today's session in successful manner. Thank you. Thank you, sir. Thank you,
Thank
one and
you.
all.
Thank you very much.
The participants kindly give the feedback, which is given feedback link.